morning. Welcome to my stream. Welcome back if you're a long-time watcher. Long-time meaning a couple months, because that's how long I've been streaming. All right, so what did we do last time? Let me switch over here. Here we go. Okay, so what we did last time was we got through part of the Synacor challenge. We're taking a small break from my roguelike stuff. Roguelike's over here still. I haven't lost it. I haven't stopped it, and I'm going to return to it as soon as I'm done with Synacor. Play a little bit and maybe die. No. Okay. Let's talk about where we were. We had just finished the third code. We have 3 of 8 codes. I'm not going to tweet about it, but I will start working on the next unhandled opcode, which is probably the last one. What's left to do? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 21. So yes, the last one to do is number 20, which if we look at the spec, how come I can't make this bigger? Aren't you supposed to normally be able to make this bigger? View. Yeah. Oh, there it goes. Okay. Well, that wasn't working. That's weird. All right. So the last opcode to write is number 20, which is read a character from the terminal and write its SE code to A. It can be assumed that once the input starts, it will continue until a new line is encountered. This means you can safely read whole lines from the keyboard and trust that they will be fully read. So let's go ahead and do that. And then I think we're going to end up playing this text game. It's 20. So what we can do, how do we read a line from Rust? Read line from standard in. How do I read a single line from standard in? Perfect. You have to lock it. Interesting. So I'm assuming that this will... Oh, it returns an iterator lines. Okay, so what we could do, I guess, is set that up right at the top. Let standard in is equal to IO. I guess standard IO. Oh, we need the buff read trait, I guess. This is use standard IO self. Is that a thing? Like that? I've never seen that before. Let's say use here. I got it backwards. Okay. Is this a thing? Standard in is equal to IO standard in. Does this check? It doesn't. Oh, because I forgot to finish 20. Okay. Yeah. Okay. Sure. And then so this gets us a let mut, I guess, because it's an iterator. Line equals standard in lock lines. And then I can just one at a time grab the lines, although I have to lock now, so I don't know if that's gonna hurt things or not. So I can just say here we want to buffer up the line, right? So our current line is going to be an option. Let my current line is going to be none. It'll be option string. We're going to want to pull off the beginning character of each one. And that's Rust string. And there's got to be a method to remove. Yeah, remove index. Okay. And it returns the character. So we just have to say remove 0. So if current, oh, what, I forgot what I just called it. Cur line is none, then cur line is some line next unwrap. Like that. And then I'm going to say let char is cur line remove 0. If cur line is empty, that means the next time we want to call it, we'll just set to none so we read the next line. And then we want to set what do? We call get arg. It says stored in A. Can I assume that's a register? In other words, am I calling get reg or am I calling get arg? Right, because get reg tells us which register we're storing to, and get arg tells us. Well, this is for read. This is for write. So I'm assuming that's a register. So let's say it's a register and see what breaks. Let reg equals machine get reg, and then we're going to say set reg machine. Is that what I called it? It's been a little too long. Set reg. Yep. Reg of ch, and then we're done. Okay, this might do the trick. No method lines for structs standard in lock in current scope. Is there an alternate suggestion here? Oh, right, I didn't add the buff reader trait. Oh, it got rid of self. Oh, that's why that's a self. Okay, so let's just change that to standard, like that. Expected string found in no results. But I did an unwrap. Do I have to do a double unwrap? Oh. Is that gonna work? Oh my god. Expected U16 found char. Okay, ch as U16. That's easy enough. And it doesn't like this. Move occurs because current line has option string which does not implement the copy street. Really? I can't check to see if it's none? Oh, because they're doing multiple iterations? This reinitialization might get skipped. Okay, maybe I don't do it as an option. Maybe I just do it as an empty string. Like that. And then instead of... Oh, supplied one argument. Okay. So no longer do it as an option, but just say cur line is empty. And then no longer this. We don't have to unwrap it anymore. And then string new. Okay. I was trying to be fancy. I guess I was being too fancy. That was a mistake. All right, so can we run this now? Cargo run. And we'll just take input. What do you want to do? Take tablet. Well, that didn't work. Oh, I bet you I have to return a new line. Let's see. This might strip out the new lines. Line next. So I can just say here, println per line is, and I'll do an open quote like that and a close quote so I can see exactly if there's a new line in there. Right, that checks. Take tablet. Yeah, there's new line. So it's looking for a new line. So what should we do? We want to insert a new line at the end of the cur line. Can we do that? Is there an extend char? Or push? Push char. Okay. There we go. Yep. Take tablet. Oh, look at that. It worked. Taken. What do you want to do? Read the tablet. I don't understand. Try help for instructions. Help. Look. You may merely look to examine the room, or you may look subject, such as look chair. Oh, I see. Look. Tablet. You may go exit to travel in that direction, such as go west, or you may merely exit, such as west. Okay, so two exits are doorway and south. Inv to see the content of your inventory. Merely inv. Take, you may take items such as take large rock. Drop to drop something in your inventory. You may drop. Use may activate or otherwise apply an item with use item. Okay, look tablet. The tablet seems appropriate for use as a writing surface, but is unfortunately blank. Perhaps you should use it as a writing surface. Use tablet. You find yourself writing on the tablet. Okay, this might be another code. Let's find out. I just have to remember what my password was. That's it. Okay, good. We got 4 codes. So if I say inv, I should see the tablet. You may merely look to examine the room. We examined the room up here. Foothills. You find yourself standing at the base of an enormous mountain, and its base to the north there's a massive doorway. A sign nearby reads keep out, definitely no treasure within. Okay, so we can either go through the doorway or go south. Let's try going south first. As you begin to leave, you feel an urge for adventure pulling you back. There's one exit north. Okay. I guess that's all what happens if you go south. So let's go doorway. This seems to be the mouth of a deep cave. As you peer north into the darkness, you think you hear echoes of bats deeper within. So I can go north and south. So do I need to start making a map now? There's some sort of whiteboard online thing, right? Alright, so we were at the foothills. I'll just say F for foothills. We went south and it was another foothills. Then we went through the doorway. I'll say doorway. And now we are in a dark cave. I can't write with a trackpad. I guess I could just use the text thing. Why don't I just use the text thing? Okay, so we're in the cave and we can go either north or south. South probably brings us back to the foothills. It does. Okay, doorway. Alright, so text. south. Brings us back to the foothills, and then north. Oh. North is going to bring us where? North. Another dark cave. The cave is somewhat narrow here, and the light from the doorway to the south is quite dim. So another cave. Okay, I guess we're going to keep going north. The cave acoustics dramatically change as you find yourself at a ledge, I guess, above a large chasm. There's barely enough light here to notice a rope bridge leading out into the dark emptiness. So we can either go over the bridge or to the south. So we're in another room now, right? Cave. And then we're going to go over a bridge. The rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. There are two exits. Continue or back. Okay. This is the bridge. And we're going to continue. Falling through the air. As you continue along the bridge, it snaps. You try to grab the bridge, but it evades your grasp in the darkness. You are plummeting quickly downward into the cavern. There is one exit down. Ha! Okay. Falling. I'll just put it over here. What if I go up? I don't understand. Okay, down. Moss cavern. You're standing in a large cavern full of bioluminescent moss. It must have broken your fall. The cavern extends to the east and west. At the west end, you think you see a passage leading out of the cavern. Oh, okay. So, what's this called? Moss cavern. Oh, I must have done two of them here. Yeah. There we go. So this was down from falling. And then it says west, you can see some sort of exit. I think you see a passage leading out of the cavern. The cavern extends to the east. There's a crevice. I think it's supposed to be crevasse, right? But yeah, ICE. Okay. Where were we? I lost my... There we go. All right. So we can either go... So we just went west. So we can go east or go into a passage. If we go east, we'll go back here. This is another moss cavern, right? And then this will be whatever comes west, east of here. So if I go back east, right now I'm just exploring to see what's going on here. It is another moss cavern over here. Okay. There's an empty lantern. Take empty lantern. Taken. Okay. Inv. So I have the tablet and the empty lantern. Okay. The cavern extends to the west. Oh, okay. So I did reach a dead end here because I can only go west. All right. So we go back to the west. The first mossy cavern, then west to there, and then we're going to go to a passage. But now we have his lantern. You are in a crevice on the west wall of the moss cavern. A dark passage leads further west. So I don't know how we can do passage here. Oh, I was trying to move it. There's no move. No. Okay. Can I select all of this? Oh, that just selects those things, not the drawing itself. Okay. All right, I'll live without having to move it. I'm probably going to run out of room, though. There's a ladder here which leads down into a smaller moss-filled cavern below. So there's 3 exits: cavern, ladder, or darkness. Oh, okay. Let me move this so it's clear that's part of this line. There we go. And then, so this will go back to cavern. I'm guessing goes back to the moss cavern. There's a ladder which goes down, and then darkness which goes to darkness. I'm going to assume that I can't see darkness. So where are we right now? It's called passage. So we use the word passage to get to passage. That's why there's 2 passages. The cavern, yes, takes us back to moss cavern. And passage takes us to the passage. We can go ladder. That's the second choice. Twisty passages. You are a maze of twisty little passages, all dimly lit with more bioluminescent moss. There's a ladder here leading up. Ladder north, south, east, west. Are we in a little maze? Do we have to solve a maze now? If I say north. Bedota says, semantically, isn't passage just the hallway? Yeah, so maybe we're in the passage right now, right? But I'm marking this. So the way I play interactive fiction games is I mark every location as a room on the map. So even though we use passage to get to the passage, it's all one passage thing. I'm sure if we sketched it for real, it would be a nice little passage. But we've took the ladder down. So now we're in this maze. If I go north, you're in a twisty maze of little passages, all alike. This is the maze of twisty little passages. This says twisty maze of little passages. So I wonder if this is going to be a hint. Let's go north again. Yeah, you're in a maze of little twisty passages. Okay, so I wonder if we can map it that way, just by the name. So I was in the ladder room. It's a maze of MTLP. Right, and this had the ladder. This one had a TMLP after we went north once. I'm not going to draw lines yet. And then we went north again and got to MLTP. MLTP. Okay, and if I go north again, I'm back to the ladder. Okay, so this loops around. So this goes here, this goes here. What if I go south? Because I want to say this north goes back to here, but does it loop around? So this is MLTP. MLTP. Okay, so it does loop around. All right. So if I'm on MLTP and I go south, I go to TMLP. Okay, so that all maps. Okay, so this is kind of a nice little loop. If I go east, okay, and a maze of alike little passages all twisty. The passage to the east looks very dark. You think you hear a grue. All right, let me move this over so I can see this map at the same time. So we started in MTLP with the ladder. We went east, which is this way, and we ended, oh, I can't do that. And we ended up in MALPT. Grue. I don't know what grues sound like, but we think that's what we hear. And that's to the east. So if I go north from here, MATP, all little. MATPL. All right, north again. MLTPA. So I'm looking here, MLTP, this says A. There's no way I'm going to get back to this, am I? We found the line. Oh, that's where we found the lantern. Okay, so if we go north, yeah, all alike. So MLTP all alike. MLTP all alike. So this may have gotten us to here. So if we go north, we get to the ladder? We do. Okay. So that's good to know. So this, if we go north from here, we can go north from here, and that takes us there. This is a one-way. Oh, I wonder if this goes east. So if I say south, I get MLTPA. If I go east, that's the same location. And I can't go west. So east just loops back to the same location. So east goes to here. So what are we missing? Oh, west, right? If I go north again, we can go west from here. A little maze of twisty passages, all like LMTPA. Okay, so that's this way. And this has north, south, and east. So if I go east, it takes us back to the ladder room. Okay, so west, that's good. North, LMTPA. So north loops back to itself. South. We're twisty alike of little passengers all make. Oh, that's funny. So it's TALPM. And this, the east passage, if you're dark, you feel like you've eaten by a grue. So this is another grue one. And this was south, right? Okay. And I just made the text bigger. I don't know why. I don't know how. I must have done it with the trackpad. All right. TALPM, all maze. So if I say north. Oh. Chiseled on the wall of one of the passageways, you see this. So if I go north, so this must be a one-way. And if I go north, it takes me to MTLPA. But no ladder. Right, the other one was MTLP with a ladder. This one does not have a ladder, and it only has one exit to the west. So I'm going to assume that the west takes us back to where we were. I can't see what I'm typing. So yeah, this takes us west to this thing, and we found a can. We have this code. Let's see if this code works. Good, 5 of 8 codes. We're getting there. Hi, Destruin. How are you? Look, can. This can is full of high quality lantern oil. Okay. Take can. Use can. You fill your lantern with oil. It seems to cheer up. I'm doing well, thank you, Destruin. I am in the middle of trying to solve the Synacor challenge. And it looks like we've stumbled into a text adventure game. Where's my map? There's my map. So we found the can. We're going to go west. There is a ladder here. Leading up. So wait a minute. So this going west from here actually took us back here. All right, so if I go to the east from here, you think you hear a grow use lantern? You light your lantern, it says. So if we go east, you're in a twisty maze of little passages all alike. TMLP. That's this. And there's north and south. So if I say south, oh, now I'm lost. Oh, now they haven't changed. Now the names aren't different. Oh boy, now I'm lost. Right? North. Yeah. North. Oh, this took us back here. Okay. So I'm not lost anymore. This might take a little bit of mapping. I wonder if I should just do it on a piece of paper here. Grab some paper. Grab a pen. Okay. I don't know how I'm going to do this mapping. I do have, what do I have in my inventory? A tablet and a lit lantern, and that's it. So if I go east now, right, if I go east, this takes us to that place where we hear a groove. If I go east again, I'm in a room that has one north exit and one south exit. And they all have the same thing. So then I went north twice, right? If I go north, I get a different room, which has a south a north, and an east. All right. And then a north again. And that takes us back to the ladder room. Okay. So then east, east gets us back to the starting location. If I say north and then south, this takes us to a room that has a north, a south, and a west. Okay. And west. Ooh. That took us to the same place. If I say drop tablet and I go west. Yeah, okay, so this takes us to the same place. Take tablet. I don't know if I'm going to need it. If I say north from here, there is a north, south, east. If I say north again, does it take us to the ladder room? It does. Okay, so there's still a couple exits we have not explored. So if I go east, east to get back to the starting room, and then we haven't looked south yet. That's a north, south, west. Drop tablet. Is this the same north, south, west room that when we go west? Yes. Okay, so going south takes us here. If we go south from this location, this takes us to the ladder room. Okay, and east to take us back to the start. So far there's only been three rooms. If we go north, the only place we haven't explored is east from here. And that also says north, south, east. Drop tablet, east. Yeah, so there's a tablet here. So I'm confused because we didn't. I think I explored every exit out of here. But we didn't see anything. Right, this is the north-southwest room. This is the north-southeast room. And if I go here, this is the ladder room. Alright, so is there something I haven't explored yet here? Oh, this first room before we get to the map, there's a north, south, east, and west. Okay, so yeah, I haven't explored to the south. That looked like it took us to the same spot. Yeah, okay. So this loops around. And then this takes us to the other maze. I'll just put an M in here for maze. But we haven't gotten anywhere now. Oh, but we do have the can with the lit lantern, so we should be able to go north to the ladder, and now we can go into the darkness, right? Because we have a lit lantern, right? Lit lantern. You feel your light source is more than sufficient to keep the crews away. There are 2 exits continuing back. Okay, so we're going through another passages here. Oh, over here. And there we go again. I've got my text doubled up. All right, we're going to continue. You're in a narrow passage. There's darkness to the west, but you can barely see glowing opening to the east. All right. And this is a dark passage. Dark passage. There we go. Let's keep going east. You feel the light source is more than sufficient. Oh wait, am I thinking wrong here? Oh, did I just go back here? Continue. There's darkness to the west. You're in a dark, narrow passage. West. West. You spot some vegetation where the passage expands. Okay, so there's a bunch of wests here. And I've lost track of how many wests I did. So continue goes to here. And then we did west, 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 west. So 4 wests. Let's say 4W. You stand in a large cavern with a huge ruin to the north, overgrown by plant life. There's a large stone archway to the north, acting as the doorway to the ruined complex. A crevice, oh, there we go. And the rock to the east leads to an alarmingly dark passage this way. There's 2 exits, east and north. So I'm assuming east will take us back to there, so north. You're in a once opulent foyer of a massive ruined complex. There is a door to the south leading to overgrowth outside, and stairs to the north which leads to a larger hall. Things of interest here, red coin. Oh, look, red coin. Coin of red, made of red metal, has 2 dots on one side. Take red coin. Okay, north. You stand in the massive central hall of these ruins. The walls are crumbling and vegetation has clearly taken over. Rooms are attached in all directions. There's a strange monument in the center of the hall with circular slots and unusual symbols. It reads, something plus something times something squared plus something cubed is equal to 399. All right. There's 4 exits. Well, we just came north, so let's keep going north. The door is locked. East. West. I was thinking east. My fingers wanted to type west. Ooh, here's a blue coin. Oh, it has 9 dots. So let me write this down here. Red had 2 dots, and blue had 9 dots. Okay. We can go up. It was a shiny coin. This was long ago a lavish throne room. Dried up fountains and crumbling statues lined the walls, and the carved stone throne in the center of the room was falling apart. Look, shiny coin. Oops. Coin is somehow still shiny. It's a pentagon on one side. So shiny. It's a pentagon. There's 1 exit down. I guess we go back east and continue east. Oh, here's a concave coin. Slightly rounded, almost like a tiny bowl. It has 7 dots on one side. Can we assume the pentagon then is 5? Take concave coin. Is down or west? What's down? Oh, there's a corroded coin. There's a triangle on one side. Okay. We can go up and west. There's a strange monument in the center of the hall with circular slots of unusual symbols. Look monument. Can we get any more clues? You see no such item. Look strange monument. You see no such item. Okay, I guess it's just in the description here. Look slots. Use slots. Oh, in your pack. It has to be in your pack. So we have a bunch of coins, I guess, we put in the slot. Use red coin. You place the red coin in the leftmost open slot. Use red coin. Use shiny coin. Use concave coin. Use blue coin. You place the blue coin into the leftmost open slot. As you place the last coin, they are all released onto the floor. Okay. Look. So maybe these are supposed to be the numbers. Because there's 5 coins and there's 5 underscores here. And maybe we need just to come up with a solution to this equation. And we know red, blue, shiny, concave, and corroded. The can was here. I'm trying to think because we're going to have to restart the game at some point. I'm trying to figure out how to get here. 4 wests. Oh, first we have to... I've forgotten where the lantern was now. We'll have to replay. Okay. So I think what we need to do is just write a quick little program to solve this equation. Right? But again, I want to be able to get back to this location. So what do? I can write a little quick program over here, I guess. This is the Synacor thing. Yeah, the problem with making this bigger is it makes the whole thing bigger. Here, hopefully I haven't ruined this. Nope. Okay. So if I... should I write a separate program here? Cargo new solver. So I think it's just this equation, right? So let's write a little Rust program to solve this. And what are the numbers we have? We have 2, 9. I'm assuming the pentagon is a 5, and the concave is 7, and then corroded is 3. I'll just write this down. Red coin is 2 dots. Blue coin has 9 dots. Shiny coin is a pentagon. Concave coin, 7 dots. And then corroded coin has a triangle. Alright, so... What's the easiest way to write this? So we can just write a little function which we can pass in all the values. And permute on the values, and then... result. A, B, C, D, E. Returns a, I don't know, E32. And that's going to say it's A plus B times C plus D times D times D minus E. Ooh. If E is too big, it might go negative. Let's do I32. And all of these are going to be I32s. Like that. Okay, so then we just need to, we have a vec that we want to permute. So Rust collection, no, it's iter Permutations. Iterate over all unique permutations of a sequence. Oh. So we need iter tools. Oh, this is... Yeah, okay. So cargo add iter tools. Hello. Okay, there's iter tools. So now we can just say at the top here, use iter tools. Iter tools. Just going to copy paste this here. And permutations. Let coins. It's going to be a vec of I32. I just want to... I guess we could just make the first one that, right? So it's 2, and then 9, 5, 7, and 3. Doesn't matter which order we do it in, right? For perm in coins. What? Items iter permutations item len. Okay. I'll just print it out like I have here. We have a couple errors. Oh, because they're not calling result. Yeah. So I guess this is all of the permutations. This makes sense. All right, so now let's call result. And actually what I can do is instead of doing this, I can just pass the whole thing in. Perm is just a reference to array of I32. And then you just say perm of 0 plus perm of 1 times perm of 2 times perm of 2 plus perm of 3 minus perm of 4. Okay, and then we can just say if results perm is 399, println perm. And let's hope that that doesn't have any borrow issues. Expected like that. No. Expected slice I32 found struct vec. Oh, it's this. Why is it that? Still an error. There we go. Okay. You got to put enough ampersands. So 92573 is the only solution. So that's blue. 2 is red. 5 is shiny. 7 is concave. And then corroded is 3. Okay. Let's switch back to the game and see what we get. What do I want to do? Take blue coin. Use blue coin. Take red coin. Use red coin. Take shiny coin. Use shiny coin. Can I say just use concave? And save a step? No. Take concave coin. Use concave coin. Take corroded coin. Use corroded coin. Aha! You place the corroded coin to the leftmost open slot. As you place the last coin, you hear a click from the north door. What do you want to do? North. Ruins. Because it has been so well protected, this room hardly shows signs of decay. The walls are covered in elaborate murals and decorated with precious metals and stones. Things of interest here. Teleporter. Take teleporter. Taken. Use teleporter. You activate the teleporter. As you spiral through time and space, you think you see a pattern in the stars. And we got another code. Oh, we're almost done. We have 5 of 8 codes. So this should be 6 of 8. That's a big code. 6 of 8 codes. Yes. Wow, we're almost done with this, huh? You stand in the lobby. This is Synacor headquarters. You stand in the lobby of what appears to be a really fun place to work. Sadly, there doesn't seem to be anyone around at the moment, so you make a note to call them later. The bookshelf here looks like it might have something interesting in it, though. Business card and strange book. Was it read or use? Use business. Oh, I have to take it. Take business card. Use business card. And there's no read, right? Yeah. And then strange book. Take strange book. Use strange book. Oh, okay. Look business card. It's business card at Synacor.com. Printed in red on one side. Okay. Look strange book. Whoa. The cover of this book subtly swirls with colors. It's titled A Brief Introduction to the Interdimensional Physics. Okay. Advances in interdimensional physics have produced fascinating predictions about the fundamentals of our universe. For example, interdimensional physics seems to predict that the universe is at root a purely mathematical construct, and all events are caused by the interactions between 8 pockets of energy called registers. Furthermore, it seems that while the lower registers are primarily control mundane things like sound and light, the highest register, so-called 8th register, is used to control interdimensional events such as teleportation. A hypothetical such teleportation device would need to have exactly 2 destinations. One destination would be used when the 8th register is at its minimum energy level. This would be the default operation, assuming the user has no way to control the 8th register. In this situation, the teleporter should send the user to a pre-configured safe location as default. Second destination is predicted to require a very specific energy level in the 8th register. The teleporter must take great care to confirm that this energy level is exactly correct before teleporting its user. If it is even slightly off, the user would probably arrive at the correct location, but would briefly experience anomalies in the fabric of reality itself. This is, of course, not recommended. Any teleporter would need to test the energy level in the 8th register and abort teleportation if it's not exactly correct. This required precision implies that the confirmation mechanism would be very computationally expensive. Although this will likely not be an issue for large-scale teleporters, a hypothetical handheld teleporter would take billions of years to compute the result and confirm that the 8th register is correct. If you find yourself trapped in an alternate dimension with nothing but a handheld teleporter, you will need to extract the confirmation algorithm, re-implement it on more powerful hardware, and optimize it. This should at the very least allow you to determine the value of the 8th register which would have been accepted by the teleporter's confirmation mechanism. Then set the 8th register to this value, activate the teleporter, and bypass the confirmation mechanism. If the 8th register is set correctly, no anomalies should be experienced, but beware, if it's set incorrectly, the now bypassed confirmation mechanism will not protect you. Of course, since teleportation is impossible, this is all totally ridiculous. What do you want to do? What do I want to do? So it's saying, so the machine has 8 registers in it, right? And if you look at the architecture that we're talking about, it has these 8 registers. So I'm assuming the 8th register is register 8 in this machine. The minimum energy level. So I'm guessing that means if it's set to 0, it defaults to sending us to the beginning of the game, which is here. And I called it F. And I forgot why I called it F. Forest, maybe? Oops. I want to look here. But if I set it to a specific value or a non-zero value, it's going to compute something, and it's saying I should extract the confirmation algorithm, re-implement it on a more powerful hardware, and optimize it. So how do we find out what the confirmation algorithm is? Because I bet you it's in this. If we look at the challenge, it's going to be somewhere in this code here. Yeah, I'm not going to find it just by paging through it like that. I was just... Okay. I guess first we need to do is try to find it. And the best way to find it would be to start it running. And then try to determine where we're running. Right, so I'd want to be able to set the 8th register to some non-zero value. Right, and this is where coming up with a way to get here would be good. Right, so I mapped everything out, so we should be able to just step through and get here, assuming that the coins all have the same values. We know the order of coins to put into the thing. What I didn't map out was where all the coins were. Dang. Okay. Let me go back and map that, because here's what I'm thinking is we'll do a few things. So this is the solver, but we don't need this anymore because now we know the order, but I'm going to keep it. So I just want to write down a few things we know. So one is we know the steps required to get to, where is this? The Synacor headquarters, right? And that's where we're getting. We know we need to set the 8th register to some value. We need to find the algorithm mentioned and optimize it. Okay. So in order to do this, I think what we can do is write down all the steps. Let's write down all the steps we need to get here. All right, so let's go all the way back to the beginning. Oh, it's just gone. Okay, but we know it's north and then down. Then north to get to the cave, north to get to the next cave. The reason I'm putting these in a little text file is so that I can just say, okay, I can tell my code to just load this text file. We went east to the bridge, we went east, and it started falling. Then we went down. We went west, we went east again to get the lantern. Right? I think the lantern was here. I should have written it down. Then we went west and west. We went passage. How did we get from passage to this? Oh, there was a ladder right there. Ladder. Then we went west, south to get to the can. Use can? I think that's what it was. And then we went east. Oh, I've forgotten. I didn't write down how we got from here to here. Oh, I've forgotten how to get there. Okay, we're going to have to replay that. All right, let's see if these commands all work. We're going to start from the beginning again, and then we have to find where each one of the coins is and write that down. Okay, so I'll kill this, start it again. Oh, it was doorway. That was the first command, was doorway. Okay, doorway. Oh, that was the dement. Okay. Then north. North. Okay, doorway, north, north. Bridge. Continue. Then down. East. Take empty lantern. Then west, west. Passage. Ladder. So west, west, passage, ladder. Yep. West. I did west then south. Ooh. Then north. And there's the can. West, south, north. Then take can. Use can. And that gets us our light. Oh, did I forget to take the lantern? That was dumb. Oh, I put take empty lantern and ignored this error message. Okay. We can go west, and that, oh, west takes us to the ladder. Okay, that's good. Good to know. West. So we're at the ladder. We should be able to go ladder. Let's go back and get the Okay, after ladder, it's west, south, north, and then take can, use can, west. West, south, north, take can. Nope, already took the can. Use can. West. Ladder. Okay, so that takes us back here, ladder. And now we can go darkness and continue. Oh. Use lantern. So darkness, use lantern. Continue. West, and there's 4 wests, right? Yeah, 4 wests. West, 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 west. And then north. Okay, so then once we go north, we can take the red coin. We can go north again. That takes us there. We can go east. I said east and my fingers type west. That's weird. There's the blue coin. So if we go west, take blue coin. We can go up and take the shiny coin. Down. East. East. Take concave coin. We can go down. Take corroded coin. Is that all of them? Oh, I forgot to take the blue coin. Or I mistyped it. Did I mistype it? Oh, I didn't even take it. Okay. No worries. I don't actually have to take it because I'm going to replay all of this. So then after we take the corroded coin, we go up. and then west. And then we're going to say use blue coin. Red, shiny, concave, and corroded. And then after that, we can look back up here, I think. How we got to this point. Oh, you know, we don't have to do any of this, right? We can just set the value on the teleporter directly. Why do we have to go through any of this? We don't have to do... Right? We can just do it right from the beginning. Well, I mean, I'm in the middle of finishing this thing anyway. I might as well just do the rest of it. Because once we... Oh no! Here's the teleporter. I thought there was a teleporter here, but we actually have to get the teleporter from this place. And then once we get the teleporter, then that's when we want to set it. So after we put the corroded coin in, we go north. Right? And then take teleporter, use teleporter. Okay. So I think these are all the steps. Let's see if this actually works. If I say cargo run less than steps, blam, it gets us all the way to, I mean, if you, right? So this all worked. And we actually got to the location where the teleport. We don't actually have to use it here. What we want to do now is actually set... Can I do that from the beginning, or is the self-test going to fail? I don't have any jobs, right? I'm thinking, you know, can we just set right at the beginning? Zero, 1, 2, 3, 5, 6. Can I just set it to 1 right there? Now I'm wondering if the self-check is going to fail. Non-zero reg. Okay, so we can't set it there. We have to wait till after. And I guess the easiest way to do it, let me switch this back here, would be once we get to the first input instruction, because we don't hit input instruction till the very first time. So I can just say machine set reg. I'll set it to 1. I have no idea if this is going to work, but let's see what happens. Okay. A strange electronic voice is projected into your mind. Unusual setting detected. Starting confirmation process. Estimated time to completion 1 billion years. But right now, it's actually running the code. So let me see if... I don't want to wait 1 billion years. So what I'm going to do is I'm going to say every time we set or read register 7, I want to print that out. Or at the 8th register, sorry. Right. So I guess what in here in getarg, we can just say if value is equal to 32775, right? That's the last register. If I can do the math in my head correctly. Yeah, 32775 is the last register. Then we're going to say, we're going to print line access value is this. Self register value as use size. Let's just do it this way. Let reg is equal to the value as use size minus 32768. That way I don't have to do math. It's 7 and 7. And then we can just say reg. Right, and then when we set the register, I want to say println if reg is 7, println right. Value changing from and that way we can see what's going on. Self register reg to val. All right, and then what we can do is say grep bang. Oops. Huh. So value change. Oh, this is because I'm doing it every time I'm in. Okay, I don't want to do it there. I just want to do it once. What's happening is every time there's an input line, it's setting this thing here. So let me just create a little boolean here. Let mut set reg is set, it's false, and then here we'll say if reg is set, we'll set it. There. Let's try one more time. Okay, so here's the write that we did. And now it's saying unusual setting. Starting confirmation process. So at this point now we are, and it's not accessing that register. I was hoping it would like try to read from the register and say what's going on. And then we'd say, okay, this is the code now that we're actually, How can we find out where we are executing right now? I guess that's the question. I'd like to see the code. I wonder if we can just write a little and I don't want to just print out every executed line because that's just gonna flood the terminal, but maybe that's a good first step is to try to figure that out. We're not going to be able to read anything, but that's all right. So we'll change this. Our IDXs are we switched back. We have the instruction. And then every time we call get reg or get arg, we can print those out as well. I guess we do that. And then get reg, we'll just say print bang r value. Space, and then get arg is going to be this will be print bang r reg in space, and then down here we'll just say print bang value in space. All right. This is going to dump out a lot of code, but that's okay. Let's see what it looks like. Oops, forgot a semicolon. Okay. Yeah, welcome to the Synacor challenge. All right, so where are we now? Because it's going to continue. It's going to continue running. But if I do this, oh, without the less, it's just going to dump, and I bet you we're in the loop now. Right? If I scroll, yeah, I can't even scroll back far enough. Or, yeah, so that's why I was trying to figure out. Oh, you know what we can do is we can enable or disable it from the prompt, right? I can just say if I can say if cur line is equal to an @ sign. Let's do that, and we can say enable dump is true. How about this? Not enable dump. That'll toggle it. And then up here we can just say let not enable dump is false. And then we can just here. Oh. Oh, I already have a dump flag. Which is not set. Okay, so we can, it's not used anywhere, but we can use it here. I forgot that I had this. There we go. So now we can say if machine.dump, do this. If machine.dump, do this. And then up in the machine, where we say print, if self.dump, do this. If self dump, I guess we want to see those. Oh, this machine.dump. There we go. Okay, so now what I can do is modify my steps. And then just before I use the teleporter, I can hit @ sign and see if that'll enable our debugging. Right? And then I can hit less here. Yeah, so now we're actually, so I hit @ and now it's executing this thing. It read in a line. I think that's what these spaces are. And then there should be a use teleporter somewhere. Right? It says taken, what do you want to do? I have, oh, I was hoping it would, oh, that's right. It's gonna say billion. It's going to print it out one character at a time somewhere. I see a blank line there, so something happened. At some point we're going to get somewhere here, right? That's too bad I didn't do this correctly. I don't know, it's printing out blank lines, so something's still happening. This is different though. Look at this. This is at 1.7 something. And all the other stuff was over here. So something changed. What's opcode 3? Opcode 3 is a pop. Do we have a 32775 here somewhere? Right, where we access it, 32775. No? Dusty Pawsey, hi. Thank you for the resub. So here's where we changed it. Somewhere we have to have access, right? Where we try to read it. I thought we did that. Okay. I'm not getting too far here. Let me see. If I do a use teleporter, it should say yeah, unusual setting detected, starting confirmation process. Why aren't I seeing the access? Oh, is that what the bug is? No, Dusty Pawsey, this is, I'm doing the Synacor challenge, which is this thing here. I've gotten 6 out of 8 codes so far, and I'm struggling to get the 7th code now. It turns out that this was a little machine that we implemented, and after we implemented the machine, it turned into a little text adventure game. And so now we go through the text adventure game, and you can see the output here of the text adventure. And it's doing this thing, unusual setting detected, and it's running an algorithm now that's going to take 1 billion years, which we want to avoid doing. So we're going to try to optimize that algorithm, but first we have to extract it. Here's the writes. The write worked. The access didn't work. I'm not seeing this. Why aren't I seeing this? Because it's definitely saying unusual setting detected. Let's take a look here. So get reg r value. Oh, I have to do it this way, yeah. Value minus 32768. Okay, so that fixes that little bug. But I'm not seeing the read. I wanted to see the access of that. So somewhere it's got to access it. Dusty, I will be getting back to the tutorial as soon as I solve the Synacor challenge, which apparently is not going to be today because I only have 20 minutes left and I'm still kind of struggling. Dusty Pawsey says, oh, it's a hiring challenge, looking for a job, eh? No, not right now. I'm pretty happy where I am. But this is similar to the Advent of Code stuff that I did earlier, or back in December, and it's made by the same guy. So a friend of mine recommended that I try it out. So let's put that back into the steps. The @sign, which is supposed to dump out everything as we do stuff. And then what I'll do is I'll just let it run for a little bit. And give it like 3 or 4 seconds, and then we can look at the output. Yeah, so it got into this 17017 area, which is what I was hoping it would do, because I think that's must be where the algorithm is, because this definitely looks like it's looping. And there's no R7? There is R7. How come I'm not seeing an access here for it then? I must have some other bug going on. Anyway, so after we do this, taken, oh, a teleporter. There it is. So here's where we said take teleporter. Here's where we did at. And then there was a bunch of stuff here. And I was hoping to see like text output. And then after a little while of all of this, we jump into this region here where we're doing this 1.7 area. Maybe these are like little subroutines. Dusty Posy says, I don't mind you taking a break from the tutorial. I take a break from Rust and doing some Zig. What is Zig? I am curious now. Is that a programming language? Home Zig programming language. I've never heard of this. What's its call to arms? What's cool about Zig? Sorry, I'm a little distracted because I am trying to find... Oh, I did see a colon. Okay. 19 is output, right? Oops. Yeah, 19 is output. So if I look at space 19 space, so these are going to be all the outputs. There's a quote, UNUSUAL. Okay, there's unusual. And so what I'm doing now is just looking for... Actually, we can just look backwards this way. So there's the space. There's another space, or a new line. Those are new lines. And there's the close quote. Period SR. Years. Yeah. YEARS. Period. Quote. New line. New line. Right, and then back to the top. Okay, so at this point now, we should be going into the algorithm that we're supposed to extract and optimize. Yeah, see, I'm seeing the reads here. I must have gotten, I got some buggy. Dusty Puzzy says, if Rust is C++, Zig would be C, kind of. Oh, okay. This looks rusty, doesn't it? Although this doesn't. This looks like JavaScript. Okay. I'll have to check that out. Thanks for letting me know, Dusty. So maybe we can try to... Okay, so we're in this region here. Where's the call instruction? Because I bet you that's the first thing it's doing is it's calling... It's 17 is call. Okay. Oh, okay. It's saying call 6027. And then it goes to 178B. Oh, because this is decimal and this is hex. Duh. Okay. So the first thing we can do is make these make these mnemonics so we can actually start seeing what's going on. And then it looks like here's where we Where's the first place we look at R7? Let's take a look at R7. How many places is that used? R7. So there's an 8. Jump if false. R7 to 5605. So here's where we're actually reading R7 for the first time to see if it's non-zero. If it is 0, then I think it's going to just dump that text out. Lusty Posy says, Zig takes a lot of things from different languages and puts it into one. Manual memory management, but use after free protection. But you can also choose to freestyle everything, just like C. Okay. So maximum danger. Nice. Right, so this is the first instruction where we're actually checking to see if R7 is non-zero. And then we jump here. So maybe this routine, 5605, I think must be 154E in hex. E5. Oops. And then for some reason the next instruction is 154E. What am I missing here? This is 15E5. Oh, jump if false. Okay, jump if false to 15E5. Right, so R7 is not 0, so it's not going to jump. So instead it's going to do these things here, which are what? Push. So it's pushing. Push 0, 1, 2. And then it's going to do a set. Okay, so here's like the beginning of the algorithm, I guess. It's doing a bunch of different things here. But it's not looping. I was hoping I would find like a... Because at some point then... Wow, what is this doing? It is calling a bunch of things. Wow, this might take a little while to extract and figure out. So let's see if we can make our lives a little easier. I'm just going forward here, and it's just looping and looping and looping and looping over the same region, and then it comes to here. Oh, you know what that is? That's the output, right? And here's our final new line, and then we go pop R1. 18 is return. All right, so we finished that routine. Oh, this must be our final new line. There must be 2 new lines there. And then we return back to this code here, and now we're calling this 6027, which must be this 17.8b, right? (178b). Okay, so I wonder if this is the fancy routine that we're talking about here. 21, 21, 21, 21, a bunch of no-ops. The 3s are pops, right? Yeah. So we're popping back our registers after having done all of that work. After returning from that routine to print the thing. Does a bunch of no-ops. It sets register 0 to 4, register 1 to 1, and then it calls this. Okay, so maybe we need to figure out what this is doing, and it'll be a lot easier if I have mnemonics. So let me put the mnemonics in, and then we'll call it a stream. And I'll make them all the same length, just to make things easier. Let mnemonic. I'll just give it a singular. Is vec, bang. So halt. set space, push, pop space. Oh, cargo format's going to make this all stretched out, isn't it? JF, add, alt, mod, Dusty Posy says, so you're implementing an ASM dialect? It's yeah, so this is a little architecture of the machine that's part of the Synacor challenge. Basically, you just read bytes from a file that's also supplied with this. And the file is just a hex file. We can take a look at it here. And it's just, 16-bit numbers define the machine. And all we do is decode each of the numbers and then execute the opcodes. Let's see, we have not, rmem, wmem, call, ret, out, in, and noop. Okay, so if I save this, it's going to... Oh, it didn't. Oh, nice. Good. I'm glad, because that would have been really annoying. And then instead of printing out inster, we're going to print out... MNE, M1IC, inster. Noop. Yeah, I'm used to no-op, N-O-P, but they have noop, so we're going with noop. Oh, this should be a usize. Okay. No problem. Easy peasy, lemon squeezy. Okay, so let's do this again. Let it run for a few seconds, and hopefully should get into the algorithm. Yeah. So now we have the algorithm. If I pop back to here, our last new line, now we can actually see what's going on. So I think this must be the beginning of the algorithm. We set R0 and R1 to 4 and 1 respectively. And then we have, oh, I should change these to hex. Let me change these to hex. Okay, 2 seconds. That should be simple enough to do. Not rreg. I still don't understand why this isn't showing up. Very confused, but here's our value, so we just say 04 hex. Give it another run. Kill it there. Yeah, so now we can see a little bit better what's going on. So call 17.8b. This does a jump of true. What we should do is actually sort these, right? Once we have the full algorithm done, so we can see what all the instructions are. I don't know how to sort hex though. Push, add, call. Oh, then call itself. Okay. And it looks like we might be doing that a lot. Here's another call, here's another call, here's another call. Right? So this is the beginning of the algorithm. But we're going to be missing a bunch of the algorithm. Oh yeah, this is doing a subtract, isn't it? We don't have a subtract. We have add mult and mod. We don't have subtract. So subtracting 1 from R0. Here's subtracting 1 from R1 and calling. Okay, so here we're actually getting a little more of the instructions. Right, so 796. So let's see if we can just pull these out here. So this is the first one, 8B. And this is 8B, 8C, 8D, so we're missing 8E. Is something. I guess we can search for that. And then after 8E is 8F, 9O. I guess we have 9.3 here. But there should be something else in here too, right? 9.3, 9.4, 9.5, then 9.6 is add. 9.6, 9.7, 9.8, 9.9, and then we have 9A, 9B, 9C, 9D. And here's AO, A2, A3, A4, A5, and A6, so 3 lines there. And this also loops back. Is there any other parts to this? Let's see if we have a 0178E. We do. Now I have too many things here. 0178E is this. So that's 8E, 8F, 9091. So there should be a 92. 01792 is a return. Okay. And 3, so we got this A6. This is A7. So you're 017A8. We have that. And that's another call. Wow. Okay, this is an interesting algorithm. So this is B1, this is B2, so 017B3. We do. Oh, that's a return. 017B4. Oops. 017. Uh-oh, what did I do? Here, 017B4. There is no 017B4. B5, B6, B7, B8, 9, nothing. Okay. All right, so this might be the whole thing then. Is this the algorithm we were supposed to extract and then optimize? Maybe we could just write this in Rust and optimize it for different values of our... So set, what does set do? Sets register A to the value of B. So here's where we read register 7. So this must be the thing that we're trying to calculate the correct value of. And then when we return, what are we expecting as a result? Okay, so that's the next question is, oops. We might have to figure out how to disassemble. Okay, so let me save this as this is our extracted algorithm. There might be a special value that needs to return, so we have to look at who's calling this. And oops, 3 lines like that. Okay, so here's our extracted algorithm. Here's where we call it. So at 156B, let me add these 3 lines. Like that. So after this, there should be some code that says, okay, what's the result? Are we staring something in like R0 and R1 or something? Let me just go through this. Jump if true, 1793. Jump if true, 17AO. Push R0. Subtract 1 and then call. Okay. (8E, 8F, 90, 91, 92). Oh, I see. Jump if true, R0. Which means is R0 not is R0 0? If it is, Then we're going to just add R0 and R1 and write that into memory location 1 and return. So whatever is in R1, so R1 gets stored in location 1 and then we return. So this is calculating some value for R1, right? And then we're going to look here. Oh no, I'm reading it wrong here. Assign into A the sum of B and C. So we're going to add 1 to R1 and set that in R0. So I'm assuming that R0 then is going to have the value we're looking for up here. Okay. But we're at the end of my stream time, so we're going to have to do this tomorrow. So let's save that. Let's quit out of that one. Here's output. I guess I don't care about the changes I made to that. And there's nothing here. Okay, so I think we're good for today's stream. Tomorrow we will go take a look at see if we can extract some more of the data around this area here and see what kind of value this algorithm should be returning. Maybe we have to re-implement this in Rust, or maybe we have to do something smarter. But we'll figure it out. I'll figure that out tomorrow. Let's see who can. I do have I have it over here. Oh, I'm the only one. I'm the only one streaming Rust right now. That's too bad. Okay. Well, thank you everyone for hanging out with me. And thanks again, Dusty Ponzi, for the resub. Much appreciated. And I will see everyone tomorrow where we hack a little bit more on the Synacor challenge. All right. Take care, everyone.